Good morning, Veritas. I, Ahmed, part of Team Nova, is about to present you our problem statement for calculating the total cost of ownership. So without wasting any more time, let's begin. So I know that you all have gone through this PPT, but we have implemented many ML algorithms like random forest and XGBoost. These are ensemble learning models. And as I said that these are all points, I'm not here to read this PPT. So just to give a glance of this architecture which we will going to follow. So user will be giving input to the front end, and from the front end, this input will be transferred through AWS console and reach to the backend. And from the backend, it will go again to the AWS services console, and there the ML models will be applied. And from there, it will be transferred back to the user in the same flow. So this is all from PPT, and these are me. So let's begin. So this is our repository, Team Nova, and we have given this readme, so feel free to read all these. So without wasting any more time, let's Nova presents Zenith. This front end was created using Tailwind, with React, and GSAP for NH, of course. So on the left hand side, you will find a control panel, which will control all the predictions which you will going to see in 5 minutes. So let's take some random inputs. vCPUs. In case you might be wondering that how are we going to get VM created and VM deleted? So you can find CloudWatch. Amazon CloudWatch provides a track of VM created and VM deleted. So you can enter them from there. Once the input fields are completely filled, it's not necessary to fill all of them. Just for the demonstration, I'm filling all of them. Let's hit click. So you can see that on the right hand side, the predicted results are on the screen. So on demand cost, which is calculated on the display. So it's like $391 per month. So this was calculated using random forest. Let's go to the random forest. This is Amazon SageMaker, which we have used for creating our ML algorithms. And this is random forest. All the dependencies are first imported, Go-to-3 client and all to connect the AWS and our S3 buckets. And then the data set is fetched from the S3 bucket. And as you can see, this is our data set with around 1500 entries. Yeah. And then pre-processing of this data takes place. After the data is pre-processed, we use the SQL inbuilt algorithms to train our model, which needs an entry point. And entry point scripts are created like this one, some inputs and predictions. Overriding has been performed. And now we have used this function to train our model. Once the model has been trained, we have done fine tuning based on whatever hyperparameters we have used. Once the fine tuning is done, the artifacts are created and once again loaded to the model. And once that is done, we have deployed the model and created an endpoint. And we will be using this endpoint later on. After that, you can also see that auto scaling is required. How? We have used XGBoost model for this to happen. And you can see model right here. It is quite similar to the random forest, provided the data set which we found had around 4 crore entries. So the accuracy, you can imagine how greater accuracy we have achieved. Got some results and then we have deployed. Once we have deployed, we have created an endpoint named autoscale endpoint. Okay. So now, after that, we will receive the auto scaling. So once this is done, we move on to this high-level vendors. There we can find many vendors which are providing these configurations. And once this is done, then you can have a clear idea of what configuration you want to have. Let's hit calculate again. You may have seen these deviations here. What are these? These are actually comparative analysis between predicted cost, Azure cost, and Amazon EC2 costs. And these are some other configurations which you may like and may have a change of mind by removing this configuration. If you want, then you can go with your own configuration, but there are others too. So feel free to explore. We can also go for medium budget. Let's make some changes. So according to that, everything has been changed. And you may have seen the deviations have also occurred respectively. And for some of the packages are not available, that's why their costs are zero. So let us see the deployment which we have done. First, the front end is stored in the S3 bucket. The required policies have to be assigned. So this is the front end and all the permissions and policies are to be assigned here. Yeah, this is all from S3 bucket. Prediction is also done. Yeah, S3. After that, the front end requires a code build, and the code build requires our GitHub repo links. So as we are implementing the CI/CD, so there are two ways. One will be using Docker Compose and all, and one will be using GitHub. So we are following the GitHub as it is very user friendly. So as you can see, the code build and all are properly done. A Zenith pipeline is created. This pipeline, there will be source, build, and deploy, and all the three actions are successfully delivered. After this, once this is done, then I'll receive a link. After all these processes are over, you'll receive a S3 link. But this link will be later on used in the backend too. So once this is done, now let's move to the backend deployment. Now let's see the build which takes place in the backend. So this is the build which takes place in the backend, and this is actually deployed in EC2 instance. So you can see that this is our Django server, which is deployed in the EC2 instance. And using this public IP, we will be interacting with it. After this is done, and all these are all the logs. So after this is done, let's move on to the pipeline. Yeah, this is our backend pipeline. So this is using Ubuntu Linux and EC2 instance. So source, build, deploy, CI/CD has been implemented successfully. Now let's go back to the code, the backend code. The very first thing that you must do when you will operate locally is to install this requirements.txt. So do pip install -r requirements.txt and install all these dependencies. So once this is done, yeah, you need to set up all the configurations, the Canicon configurations, then the Nginx configurations, the booting scripts, the app specs YML, the build spec YML. So once all this is done, you must go to the settings.py, and this settings.py, you have to create a Django app and allow course origins. So this is our S3 bucket of frontend, which is being allowed. Oops. Yeah. Once this is done, let's move ahead. This is our view.py. This is where the REST APIs are called. The REST APIs which are deployed in ML are called. And this is where we fetch our dataset from. This is the searching dataset which we are fetching locally. And all the methods are written correctly. And these are the endpoints. Now, how we have got these endpoints? For that, you must create Lambda functions first. So you can see this Lambda function, which is here. So this is the Lambda function. And it requires a endpoint name. And this environment variable is written here. So you might have created so once we have created an endpoint, we must name it, and then name should be provided to the environment variable. Permissions should be provided. All the respective IAM policies should be provided, and without them we can not basically access the whole SageMaker. So this is what we have to do, and then we have to create REST APIs. So there are two REST APIs, one's for auto scaling, another is for the random forest. So basically we are using post method, and for this we have to create a post method API. Once you have created a resource, you have created a method and named it properly, we have used testing to test it. Once it is ready, we have to deploy it. We also have to check them through Postman whether they are successfully working before going to any coding or not. So we have to enter the format in this format, in a text data, text/CSV, and then prediction will take place. So this time it predicts 0. 0 means that auto scaling is not required. 1 means that auto scaling is required. So this is basically XGBoost classification taking place. So once all these checking have been done, we are ready to go to the backend and use our API. So once we call the API, we create a payload, we create a header, and then we send a request post along with the URL headers and payloads. Once this is done, then we are also calling other functions for our competitive analysis. So we have to do all this stuff, and then there are some filtrations. This is the search function which we have used basically to categorize between low, medium, high budgets. And once this is done, a dictionary is created and sent to the front end, consisting of the different vendors' informations. And graph is also created using these codes. So you have this repo, so you can feel free to inspect all this code. Now let's move on. So this is basically the all the changes which is required and handle submit. This is actually the most important. If you are running it locally, please use this URL. Don't use the public IP URL. And right now everything is exposed because uh, .env file, there is no meaning of creating .env file because this code will be given to the Veritas company and the evaluation will be taking place. So we have not used any secrets or env files. So everything is exposed right now as it is just a hackathon. So, but in professional life, make sure that you will use the env files and all. So yeah, after this, yeah, it's just a front end and all, and very complicated code. So as I said that I like UI UX, so this is what we came with. And now let's discuss our business model. A user should use Cloud Zenith. Not only it provides an estimation, a probability of whatever type of instance memory, say memory buckets, all the configurations, whatever configurations the user wants, they can get it. But apart from that, they will get a deep analysis. I mean, sometimes what happens is people go ahead and buy uh, much more expensive configurations when they have a very basic works to do. Like for example, if a user wants to use, let's say, um, what? Let's say E16 B5, and the work which it needs to be done is only requires standard F1. That means a lot of hardware has been wasted. In this comparative analysis, we get a glance of what work will be done in less budget with around that configurations. So this is what the competitive analysis does. In the future scope, we want to include some more advanced features like generative AI. This time, the time was very less for work, so that's why we were about to go for Llama 2 model, which was present in AWS SageMaker, but it's a little complex, and the endpoint creation is also a little complex. So it requires more time, basically. Another thing which I was, and another thing which we were coming with was like being an AIML student. It's very confusing that which things are to be selected. These are all very complex for others. So making things very easy, we came with another idea at the very last moment. Like, what if we ask some questions like, what kind of business are you running? What kind of storage facilities do you need? Is your Do you require scalability in your business, etc., etc. And these questions will give some outputs. Those outputs will be given to random forest. Random forest creates rules, and these rules will later on lead to one output. That output will be the favorable vendor, and that is how it will work. So this is all our future scope. Thank you for letting MIT Academy of Engineering being a part of Uconnect Veritas Hackathon.